we're talking about equilibrium. When an object is in equilibrium, all the forces cancel each other out. The forces that are up balance the forces that are down. The forces that are left balance the forces that are right. There is no acceleration. Either the object is at rest, which is one that students pick up on real quick, or it's moving with a constant velocity, which is one that students often overlook. You can be moving and in equilibrium. You just have to be moving at a constant velocity, which means you're maintaining your same speed and going the same direction. So tips for solving force problems. Step 1, draw the free body diagram. Okay? Step 2, write your givens. Step 3, what you're trying to find. Step 4, the equations. Okay? The free body diagram directions are the same as before. I just put them here as a reminder. We're going to refer back to them once we do the problem. And then for the equations, are you in equilibrium? If yes, you're going to use the equations that the net force in the x direction is 0. They balance each other out. And the net force in the y direction is 0. They're going to balance each other out. If you're not in equilibrium, if you are accelerating, you'll use the bottom equation. We'll get there eventually. Right now we're working on equilibrium problems, so we're going to end up using these equations. Okay, so we're going to do part A in this problem. A museum curator moves a 145 kilogram aluminum sculpture across a horizontal platform. It takes a force greater than 870 newtons to move the sculpture. What is the coefficient of static friction between aluminum and steel? Okay, here's just a general picture. I'm going to draw up a free body diagram. We know we have a horizontal platform. A horizontal platform. And I'm going to draw a dot to represent my sculpture. You can go back and look at my tips for drawing a free body diagram. Gravitational force is almost always present. And yet there's gravity because this museum is on or near Earth, on Earth. We've got a gravitational force. Okay? Alright. Then, if there's a surface, what's on a surface? A horizontal surface. Then there's a normal force perpendicular to the surface. There's a normal force pointing straight up. Okay? If there's a surface, then there might be friction. Well, the museum curator is pushing on it, but it doesn't move because it takes a force greater than 870 to move it, and he's going to push with a force of 870. It's not going to move, but the reason it's not moving is because of that friction. So I'm going to pretend this museum curator is pushing to the right, which means friction is going to the left, and it's static because it's not moving yet. Okay, and then we'll go back. We've got our friction. There's no string or rope, so there's no tension. The applied forces are given to you. The museum curator is going to push on this with a force of 870 newtons. That's my applied force. So there's my free body diagram. So after we have our free body diagram, I want to write down what we're trying to find. What is the coefficient of static friction? That is U of S. And we forgot a step. We drew the picture. We didn't write down our givens yet. I have to find. We didn't write down our givens. So in our givens, the museum curator moves a 145 kilogram aluminum statue. So that is the mass of the statue. The mass of the statue is 145 kilograms. It takes a force greater than 870 to move it, but he's going to push on it with a force of 870, and it's just not going to move quite yet. And that's it. So, looking at this, I'm like, okay, well, I know the applied force. I don't know any of the other ones. But what I do know is that I know how to find the gravitational force. We have an equation on our equation sheet, and we've practiced before. The gravitational force is the mass times the gravitational field constant. So the gravitational force is 145 kilograms times Earth's gravitational field constant of 9.81. So the gravitational force is 1,422 and 4,500 newtons. Okay, so we've got a little further. Okay? I wrote down what I'm trying to find. Maybe I'm going to look for the equation next. There's only one equation with the coefficient of static friction in it. And that is the force of static friction equals the coefficient of static friction times the normal force. So I write it down. I look at my givens. I say, all right, don't have static friction. Don't have normal force. I'm stuck. Then I remember, hey, we got a hint. Here are some equations you can use if you're in equilibrium. If you're in equilibrium, the net force in the x is 0, and the net force in the y is 0. I'm going to write that down. Net force in the x direction is 0, and the net force in the y direction is 0. Well, what does that mean? That means the forces in the x direction are balancing each other. So the left forces are balancing the right forces. Okay? Well, what forces are pointing to the left? There's only one, static friction. What forces are pointing to the right? There's only one, the applied force. All right, so this is going to help us figure some things out. Let's see. The applied force is 870 newtons. Well, that means we now know static friction is 870 newtons. They have to balance each other out because it's in equilibrium. It's not moving. So we're going to be able to, we now know static friction. Okay? And let's see if we can figure some more out going to the y direction. It's not accelerating up or down either. So that means the up forces are balancing the down forces. What force is pointing up? The normal force. What force is pointing down? The gravitational force. Okay, I know the gravitational force. So I'll substitute in for the gravitational force 1,422 and 4,500 newtons. And the normal force, well, because we're in equilibrium, it's the same. Now, they're not always going to be exactly the same. Okay? If there's more than one, like if there were two pointing to the left, those two would have to add up to be the one pointing to the right. And that will happen in some of our more complex problems. But right now, we just have one on each side, so they're equal. Okay? So now we know the normal force. Now we can go ahead and substitute into this equation. So static friction is 870 newtons is equal to the coefficient of static friction times the normal force, 1,422 and 4,500. Divide both sides by 1,422 and 4,500. You get the coefficient of static friction is 0.61. And there are no units. It's just telling us how rough or smooth the two objects are. The smaller the number, the smoother they are, and the bigger the number, the rougher they are.